A very good morning, dear students. Myself, Professor Satish Shinde from the Department of Mathematics, KLS, VDIT, India. So, in the previous session, we studied about how to derive the expression for the CR equation in Cartesian form and polar form. And what do I mean by analytic function? Now, we'll see how to construct an analytic function. Now, there is one method which we call it as a Milnes-Thomson method. Milnes-Thomson, it is the name of the mathematician who have discovered the how to construct an analytic function by if real or imaginary part is given. Means, as you know, the real or imaginary when u or v is given, how to find out the remaining part, that is if the real part is given, how to find out imaginary or vice versa. So the procedure says that first step, if u or v is given, find ux, uy, vx, vy. Consider f dash of z is equals to ux plus I into vx. Let u is given by CR equation, so vx is equals to minus uy. Then f dash of z is equals to, instead of ux plus I into vx, you replace it by ux minus I into uy. Then third step, put z is equals to 0 and y is equals to 0. Put x is equals to z and y is equals to 0 to obtain f dash of z as a function of z. Then integrate with respect to z, we get f of z. Similarly, in polar form, f dash of z we need to take it as e raised to minus I theta into ur plus I into vr. So where vr is equals to minus 1 by r into u theta. When u is given or u in that or v is given, in that case ur is equals to 1 by r into v theta we can use. Then putting r is equals to z and theta is equals to 0, obtain f dash of z as a function of z. Integrate with respect to z, we get f of z. For example, first one, find the analytic function whose real part is u is equals to log of square root of x square plus y square. Solution. Given u is equals to log of square root of x square plus y square, which is can also be written as 1 by 2 times log of x square plus y square. Then ux is equals to 1 by 2 times 1 by 2 into 1 upon x square plus y square into 2x, which can be written as x upon x square plus y square. And uy is equals to y upon x square plus y square. Now consider f dash of z is equals to ux minus I into ux plus I into vx, but vx can be written as minus of ui by CR equation, that is f dash of z is equals to ux minus I into ui. Substitute for ux and ui, we will get x upon x square plus y square minus I into y upon x square plus y square. Put x is equals to z and y is equals to 0. In that case, you will get f dash of z is equals to 1 by z, which we integrate, it will be integration of 1 by f dash of z is f of z, integration of 1 by z is log z, plus the constant of integration c, which is the required analytic function. Now, second example, construct the analytic function f of z whose imaginary part is given by e raised to x into x sin y plus y cos y. Given v is equals to e raised to x into x sin y plus y cos y. Now differentiate partially with respect to x and y, which we denote it by vx and vy. So vx will become x e raised to x into sin y plus x sin y plus y cos y. Vy will be equals to e raised to x cos y minus y sin y plus cos y. Now f dash of z is ux plus I into vx. Then by CR equation, ux is equals to vy. F dash of z is equals to vy plus I into vx. So putting x is equals to z and y is equals to 0. In that case, we will get f dash of z is equals to e raised to z into z plus 1. Now if you integrate this, f of z will be equals to integration of z plus 1 into e raised to z plus c. Now this integration is with respect to integration by parts. So taking z plus 1 as the first function, e raised to z as the second function, and integrating, that is z plus 1 into e raised to z integration is e raised to z minus, under integral sign, differentiation of z plus 1, it is 1 into e raised to z integration is e raised to z. So again integration of e raised to z. So e raised to z get cancelled. So we're left with z into e raised to z plus constant of integration c, which is the required analytic function. Now third one, construct an analytic function whose real part is r square into cos of 2 theta. Now given u is equals to r square into cos of 2 theta. Now since it is in polar form, so find out dou u by dou r and dou u by dou theta. That means u r, u suffix r and u theta. U r is equals to 2r cos 2 theta. U theta is equals to minus 2r square into sin 2 theta. And f dash of z is equals to e raised to minus I theta into ur plus I into vr is equals to e raised to minus I theta into ur minus I into u theta by r. Now that will becomes, that is f dash of z will be equals to 2r e raised to minus I theta cos theta plus I sin 2 theta. Putting r is equals to z and theta is equals to 0, we will get 2z. F dash of z is 2z. So which when integrate, we will get f dash of z, f of z is equals to z square plus c, which is the required analytic function. Next one, show that u is equals to x cube minus 3xy square plus 3x square minus 3y square plus 1 is harmonic, and find its harmonic conjugate. Also find the corresponding analytic function. Now given u is equals to x cube minus 3xy square plus 3x square minus 3y square plus 1. Differentiate u partially with respect to x twice. So uxx will become 6x plus 6 and uyy will be equals to minus 6x minus 6. If you add this uxx plus uyy, it will become 0. Hence u is harmonic. Now dou u by dou x is equals to 3x square minus 3y square plus 6x. And by CR equation, you know that it is dou u by dou y. Name this as equation 1. And dou u by dou y is equals to, here dou u by dou y is equals to minus of minus 6xy minus 6y, bracket complete, which is nothing but dou u by dou x. Name this as equation 2. Now from equation 1, v is equals to integration of, now you can see that if you from equation 1, dou v by dou y is equal, dou v by dou y is 3x square minus 3y square plus 6x. Now if you integrate dou v by dou y with respect to y, you will get v is equals to integration of 3x square minus 3y square plus 6x into dy plus the constant of integration. Here we are going to take the function, next function will be as a constant, means x will be constant, so we will take f of x as a constant. So and from equation 2, v is equals to difference integrating with respect to x, treating y as constant, it becomes v is equals to integration of 6xy plus 6y into dx plus g of y, where fx and g of y are constant of integrations. Now if you integrate first one, then you will get v is equals to 3x square y minus y cube plus 6xy plus f of x, and v is equals to 3x square y plus 6xy plus gy. We have to choose fx and gy in such a way that we will get a unique expression for v. Let f of x is equals to 0 and g of y is equals to minus of y cube. Therefore v is equals to 3x square y minus y cube plus 6xy. Also we have to find the function, analytic function f of z. So f of z is equals to, you can see that f of z is ux plus I into vx. So it is x cube minus 3x square, 3xy square plus 3x square minus 3y square plus 1 plus I into 3x square y minus y cube plus 6xy. So putting x is equals to z and y is equals to 0, we will get f of z is equals to z cube plus 3z square plus 1. With this, I conclude today's session. To summarize the topic, at the end of the topic, students will understand how to construct an analytic function. Here I have given some additional reference as a YouTube channel, so I request each and every one of you to go through this. And in the next class, we will be studying some few more examples based on how to construct an analytic function. So with this, I conclude today's session. Thank you.